Ladies and gentlemen, hello once again and welcome back to the Hot Technologies webcast series. My name is Eric Cavanaugh. I'll be your host for today's web seminar called Saving Time, Money, and Trouble with Optimal Forecasts. Of course, I missed the first part of the title there, the best laid plans. We always talk about that on this show. So Hot Technologies, of course, is our forum for understanding what some of the cool products are out there in the world today, in the world of enterprise technology, what folks are doing with them, how they work, all that kind of fun stuff. And the topic today, as I suggest, deals with forecasting. Really, you're trying to understand what's going to be happening in your organization. How are you going to keep your users happy no matter what they're doing? If they're doing analysis, if they're doing real work, if they're facing customers with transactional systems, whatever the case may be, you want to understand how your systems are running and what's going on, and that's what we'll talk about today. And it's kind of funny because forecasting is not something I like to do because I'm superstitious. I think if I forecast too much, bad things will happen, but that is just me. Don't follow my lead. So here are our presenters today. Yours truly in the top left-hand corner. Rick Sherman is dialing in from Boston, our buddy Bullett Manale from IDERA, and our very own Dr. Robin Bloor. And with that, I'll hand it over to Robin. And just remind folks, ask questions. Don't be shy. We love good questions. We'll put them out to our presenters today. And with that, Robin, take it away.
Okay. Well, as I'm in the pole position, as they say, I thought I'd tell the SQL story today because it's a background for what's the discussion that's going to go on. And it will inevitably not clash with, because Rick is not focusing on this, it will not clash with what Rick has to say. So the SQL story. There are some interesting things about SQL because it's so dominant. You know, see, well, that's a typo. The SQL is a declarative language. The idea was that you could create a language in which you would request what you wanted, and the database would work out how to get it. And it's worked out rather well, actually, but there are a number of things that are kind of worth saying about it. You know, the consequences of basing the whole of the IT industry on a declarative language are, you know, the user does not know or care about the physical organization of the data. And that's the good thing about the declarative language. It separates you out from all of that. You needn't worry about it. Just ask for whatever you want, and the database will go and get it. But the user has no idea whether the way they structure the SQL query is going to affect the performance of the query. And that's a bit of a downside. I've seen queries that, you know, hundreds and hundreds of lines long that are just one SQL request, you know, begins with select. And it just goes on and on and on with subqueries and so on and so forth. And it actually turns out that there are, you know, if you want a particular collection of data out of a database, you can ask for it in many different ways with SQL and get the same answer if you kind of have some familiarity with the data. So, you know, one SQL query isn't necessarily the best way to ask for data, and databases will respond quite differently according to the SQL that you put into them. And so SQL actually affects performance. So people that use SQL, it's true of them. It's also true of the SQL programmers that use SQL. And they're even less likely to think about the impact that they're going to have because most of their focus is actually on the manipulation of data and not on the getting and putting of data. And the same is also true of BI tools. I've seen the SQL that gets, if you like, squirted out of BI tools at various databases, and it has to be said that a lot of that is, well, I wouldn't write SQL queries like that, you know. It's not, it's somebody has created, if you like, a little motor that whatever the parameters are, it'll throw out some SQL. And again, you know, that SQL will not necessarily be efficient SQL, you know. Then I thought I'd mention the impedance mismatch. The data that programmers use is different than the data as it's stored. So, you know, RDMS stores data in tables organized. The object-oriented code are mostly programmers are coding in object-oriented data, in object-oriented form nowadays. They order data in object structures, you know, so it doesn't map one to the other. So there's a necessity to translate from what the programmer thinks the data is to what the database thinks the data is, which seems a bit, it seems like we must have done something wrong for that to be the case. SQL has DDL for data definition, it has DML, data manipulation language, select, project, and join for getting at data. It has very little math and very little time-based stuff, so it's an imperfect language, although it has to be said it has been extended and continues to be extended. And then you get this, the SQL barrier problem, which is illustrated in that diagram, in that a lot of people are asking questions for analytical reasons. Once they've got the answer to the question, data terms, want to ask another question. So it becomes a dialogue thing. Well, SQL wasn't built for dialogues. It was built for asking what you want all at once. And it's kind of worth knowing that, because there are some products out there that actually forsake SQL in order to make conversation possible between the user and the data. In terms of database performance, and this kind of spreads out to everything. Yes, there's CPU, there's memory, there's disk, there's network overheads, and there's a locking problem of more than one person wishing to have exclusive use of the data at a given point in time. But there's also poor SQL calls. There's an awful lot that can be done if you actually optimize the SQL in terms of performance. So database performance factors: bad design, bad program design, concurrency or workload mixing, load balancing, query structure, capacity planning. That is data growth. And in a few words, SQL is convenient, but it doesn't self-optimize. And having said that, I think we can pass on to Rick.
All right, Rick, let me give you the keys to the WebEx car. Take it away.
All right, great. Well, thanks, Robin. As we started off in the beginning of the presentation, my graphics are still pretty boring, but we'll go with it. So I agree with everything Robin talked about on the SQL side, but what I want to concentrate a little bit now on sort of the demand for data, which we'll go through very quickly, the supply, and then the tools used in that space, or the need for the tools in that space. First off, there's certainly every article you read has to do with big data, lots of data, unstructured data coming from the cloud, big data everywhere that you can imagine. But the growth of the database market has continually been with SQL. Relational database, probably as of 2015, is still 95% of the database market. The top 3 relational vendors have about 88% of the market share in that space. So we're still talking, as Robin talked about, SQL. And in fact, even if we're looking on the Hadoop platform, Hive and Spark SQL, which my son, who's a data scientist, uses all the time now, is certainly the dominant way for people to get to data. Now, on the database side, there are 2 sort of broad categories of usage of databases. One is for operational database management systems, so enterprise relationship planning, customer relationship management, so the Salesforces, ERPs, Oracles, Epics, Infowars, et cetera, of the world. And then there's a wide and expanding amount of data that's in data warehouses and other business intelligence-based systems, because everything, regardless of where and how it is captured, stored, or transacted, eventually gets analyzed. And so there's a huge demand and increase in the use of databases, particularly relational databases out in the marketplace. Now, so we got the demand. We have huge amounts of data coming, and I'm not really talking just about big data. I'm talking about the use of data across all sorts of enterprises. But accompanying that, from a supply side, for people who can manage those resources, we have, first off, we have sort of a DBA shortage. We have, according to the Bureau of Labor Statistics, from 2014 to 2024, the DBA jobs are only going to grow by 11%. Now, that's people who have DBA job titles. We're going to talk about that in a second, versus the 40+% annual data growth space. And we have a lot of DBAs. On average, that same study talked about the average age is pretty high compared to other IT professions, and then we have a lot of people leaving the field, not necessarily retiring, but shifting into other aspects, going into management or whatever. Now, part of the reason they're leaving is because the DBA job keeps getting harder and harder. First off, we have DBAs managing many different databases themselves, physical databases located all over the place, as well as different types of database systems. Now, that may be relational, or there may be other types of databases too, but even if it's relational, they could have any one of 2, 3, 4 different vendors that they're actually trying to manage. DBAs typically get involved after the design of the database or the application. As Robin talked about how databases or applications get designed, how SQL gets designed. Well, when we're talking about data modeling, ER modeling, extended ER modeling, dimensional modeling, advanced dimensional modeling, whatever, typically application programmers and application developers design with their end goal in mind. They're not designing for the efficiency of the database structure itself. So we have a lot of poor designs. Now, I'm not talking about the commercial enterprise application vendors. They usually have ER models or extended ER models. But what I'm talking about is there's a lot more business processes and applications being built by application developers in every company. Those are the ones that aren't necessarily designed for efficiency or effectiveness of deployment. And the DBAs themselves are sort of overworked. I mean, they have 24/7 responsibilities sometimes. They keep getting more and more databases. I think that has to do a little bit with that people don't quite understand what they do or how they do it. There's sort of their own little group. And people just keep thinking, well, all these tools are so easy to use, we could just keep throwing on more and more databases on their workload, which isn't the case. Which leads us to the part-time and accidental DBAs. We have IT teams that are small, and they not necessarily afford a dedicated DBA. Now, that's true of small to medium-sized businesses where the expansion of databases and database applications has exploded in the last decade and continues to expand. But it's also the case of large corporations. Typically, I've been doing data warehousing, business intelligence, analytics for a long time. A long time ago, we used to get dedicated DBAs for those projects. We never get a dedicated DBA anymore. We're responsible for designing the database, which is fine if it's somebody who has experience. But in general, the DBAs are application developers. They often take that role as a part-time part of their job. They don't have formal training in it. And again, they're designing it for their end goal. They're not designing it for efficiencies. And there's a lot of difference between design and development as well versus deployment and management. And so we have sort of the penny wise, pound foolish with a little piggy bank there, people skipping on getting the skills and the resources needed for the projects, thinking that everybody is from Revenge of the Nerds, my little picture there. Now, as far as what people need, so we have an expanding need for use of data. We have an expanding usage of databases and data in SQL. We have a constrained number of DBAs, people who are skilled and experts at these tuning and designing and managing and deployment situations. And we have more and more part-time or accidental DBAs, people who haven't had the formal training. So what are some of the other things that are sort of also kind of getting into the issue of the fact that these databases aren't being tuned as well or managed as well? First off, many people assume that the database management systems themselves have sufficient tools in order to manage themselves. Now, the tools are getting easier and easier to do design and development, but that's different than doing a good design and a good managing capacity planning, monitoring, et cetera, for deployment. So first off, people assume that they have all the tools they need. Second off, if you're a part-time or accidental DBA, you don't know what you don't know. I guess I forgot some of the phrase there. So that a lot of times they just don't understand what they even need to look at in the design or when they're managing or operating the databases. If that isn't your profession, then you're not going to understand what you need to do. The third one is that SQL is a go-to tool. So Robin talked about SQL and how poorly SQL sometimes is constructed or often is constructed. And also one of my pet peeves in the BI, data warehousing, data integration, data engineering space is that rather than using tools, people have a tendency to write SQL code, stored procedures, even if they're using an expensive data integration tool or an expensive BI tool. They often really use it just to run stored procedures, so that the importance of understanding database design, of constructing that SQL, is getting even more and more important. And finally, there's a silo approach in that we have people look at individual databases. They don't look at how the applications work and interact with each other. And they also are really often looking at the databases versus the applications that they're used for. So the workload that you get on the database is critical in the design, and critical in tuning it, and critical in trying to figure out how to plan for capacity, et cetera. So the sort of looking at the forest from the trees, people are in the weeds looking at the individual tables and databases and not looking at the overall interaction of these applications and the workload. Finally, people need to look at the key areas that they need to look at when they're planning to manage databases. They need to first think about develop some application-centric performance metrics. So they need to look at not just sort of how this table is structured, or how it's particularly modeled, but how is it used. So if you have an enterprise application that's doing supply chain management, if you're taking orders off the web, if you're doing BI, whatever you're doing, you need to look at who's using it, how they're using it, what the data volumes are, when it's going to happen. What you're really trying to look for is the wait times, because no matter what, all applications are judged by how long it takes to get something done, whether it's a person or just an interchange of data between applications or processors. And what are the bottlenecks? So often when you're trying to debug issues, of course, you're really trying to look at what are the real bottlenecks, not necessarily how to tune everything, but how do you get rid of and move the performance up to wait times and throughput, whatever you need to look at. And you need to sort of separate out the data capture, the transactions and transformations aspects in the database, along with the analytics. Each of those have different design patterns. Each of them have different usage patterns, and each of them need to be tuned differently. So we need to think about how this data is used, when it's used, what it's used for, and figure out what the performance metrics are and what are the key things you want to analyze related to that usage. Now, when you're looking at monitoring the performance, you want to look at the database operations itself. So you want to look at both the data structures, so the indexes, partitioning, and other physical aspects of the database, even the structure of the database, whether it's an ER model or a dimensional model, or however it's structured. All those things are going to have an impact on performance, especially in the different contexts of data capture, analytics, and the transformations that happen. And, as Robin mentioned on the SQL side, looking at the SQL that's being run by these different applications across these databases and tuning it is critical. And looking at the overall application workloads and the infrastructure environment that these databases and applications run on. So the networks, the servers, the cloud, whatever they're running on. Also looking at the impact that these applications and these databases have within that context. All these have an interplay of being able to tune the database. And finally, when you're looking at tools, you want to be able to look at the 3 different kinds of analytics related to that. You want to look at descriptive analysis, what's happening and where related to the database and the application performance. You want to have the ability to do diagnostic analytics to figure out not only what is happening, but why is it happening, where are the bottlenecks, where are the problems, what's running well, what's not running well, but being able to analyze and drill down into the problem areas in order to address those, for either for design or whatever you're going to need to do. And finally, the most aggressive or proactive type of analysis is to actually do some predictive analysis, predictive analytics, modeling, whatever, of we know that the database and the applications work in this context. If we up the capacity, if we get more users, if we do more throughput, whatever we're doing, being able to project out what, how, and where that will impact the database, the applications, allows us to plan for and figure out proactively where the bottlenecks are, where the wait times might suffer, and what we need to do in order to fix things. So we want to have tools that are able to implement the performance metrics, monitor the performance, and then do these 3 types of analysis. And that's my overview.
All righty. Let me hand it off to, those are 2 great presentations, by the way. Let me hand this off to Bullett Manale to take it from there. And folks, don't forget to ask some good questions. We have some good content already. Take it away, Bullett.
Sounds good. Thanks, Eric. So a lot of what Rick said and Robin said, obviously, I agree with 100%. I would say that I pulled this slide up because I think it's fitting. I mean, I don't know if you, for those of you that are A-Team fans back in the 80s, you know, John Hannibal had Hannibal Smith had a saying he'd always say, "I love it when a plan comes together." And I think that, you know, when you're talking about particular to SQL Server, which is where we're focusing with the product that we're going to talk about today, SQL Diagnostic Manager, it's definitely one of those things that you have to be able to leverage the data that you have and be able to make decisions from that data. And in some cases, you're not looking for a decision, you're looking for something to tell you, you know, when something is going to run out of resources, when you're going to run out of resources, when you're going to have a bottleneck, those kinds of things. It's not just about monitoring a specific metric. So with Diagnostic Manager, one of the things it does is very well going to help you in terms of forecasting and understanding specific to the workloads, and we're going to talk about a lot of that today. The tool is geared for the data manager, the DBA, or the acting DBA. So a lot of the things that Rick was mentioning about the acting DBA is so true. In a lot of cases, if you're not a DBA, there's going to be a lot of question marks that you're going to have when it comes time to managing a SQL environment. Things you don't know, and so you're looking for something to help you, kind of take you through that process, and also educate you in the process as well. And so it's important that the tool that you use for those kinds of decisions is going to give you some insight into the reasons why those decisions are being made. It's not just telling you, hey, do this. Because if I'm the acting DBA, eventually I might be the full-blown DBA with the actual expertise and knowledge to back that title up. So that said, you know, when we're talking about being a database administrator, I always kind of show this slide first because the DBA has, you know, some different roles, and depending on the organization that you're with, you're going to have, those are going to vary from one place to another, but typically, you know, you're always going to be in some way responsible for your storage, your planning of that storage, and understanding of, you know, how, anticipating, I should say, how much space you're going to need, whether it's for your backups or whether it's for the databases themselves. You're going to need to understand and assess that. In addition, you're going to need to be able to understand and optimize things on an as-needed basis. And as you kind of go through the monitoring of the environment, it's obviously important that you make changes as they're needed based on things that change within the environment itself. So things like the number of users, things like the popularity of applications, the seasonality of a database, all should be considered when you're doing your forecasting. And then obviously looking at other things in terms of being able to provide the reports and the information that's necessary as it relates to making those decisions. In a lot of cases, that means doing comparative analysis. It means being able to look specifically at a particular metric and understand what the value of that metric has been over time so that you can anticipate where it's going to move forward. So a lot of what the tool Diagnostic Manager has those capabilities, and people use it every day for being able to do things like forecasting. And I put the definition here of capacity planning, and it's pretty broad and actually pretty vague definition, which is just the process of determining the production capacity needed by an organization to meet the changing demands for its products. And at the end of the day, that's really what it's all about. It's about being able to take information that you have some way or another and taking that information and making decisions to help you move forward as you progress through the life cycle of your databases. And so, the types of things that are the reasons why people need to do this are obviously, first and foremost, in most cases, to save money. Businesses obviously, that's their main goal, is to make money and save money. But in the process, along with that, that also means being able to make sure that your downtime is there's no downtime, and being able to make sure that you mitigate any chance of downtime occurring. So keeping it from happening to begin with, in other words, not waiting for it to happen and then reacting to it, as well as being able to overall increase the productivity of your users, making them more efficient so that you can get more business done is obviously the key here. And so these are the types of things that as the DBA or somebody involved in forecasting or capacity planning is going to have to be able to wade through the information to be able to make those decisions. And then overall, this is going to obviously help you eliminating waste, not just waste in terms of money, but also in terms of time and in terms of just generally resources that can be used for other things possibly. So, being able to eliminate that waste so that you don't have opportunity costs that are tied to the waste itself. So with that said, what are the types of questions that we get specific to the person that's a DBA? When am I going to run out of space? That's a big one. Not only, how much space am I consuming now, but when am I going to run out based off the trends and the past history. Same thing with the actual instances of SQL, the databases, which servers can I consolidate? I'm going to put some on VMs. What makes sense in terms of which databases I'm going to consolidate, and which instances of SQL should they reside on? All those types of questions need to be able to be answered because in most cases, if you're a DBA or acting DBA, you're going to consolidate at some time in your career. In a lot of cases, you're going to be doing that on an ongoing basis. So you need to be able to make those decisions quickly, not play guessing games when it comes to that. We talked about bottlenecks and where they're going to occur next, being able to anticipate that once again instead of waiting for them to happen. So obviously, all of these things we're talking about make sense in the sense that you're relying on historical data in most cases to be able to generate these recommendations, or in some cases be able to formulate decisions yourself to be able to come up with these answers. But it reminds me of the when you see or hear the radio ads for somebody selling securities or something like that. It's always past performance is not indicative of future results and those kinds of things. And the same thing holds true here. You're going to have situations where these forecasts and these analysis may not be 100% right, but if you're dealing with things that have happened in the past and the known, and being able to take and kind of do the what if with a lot of these types of questions you're going to run into is very valuable, and it's going to get you a lot further than playing the guessing game. So these types of questions obviously are going to come up. Now, so how we handle a lot of these questions with Diagnostic Manager, first of all, we have forecasting capabilities, being able to do this at the database, at the table, as well as the drive or the volume, to be able to not only say, hey, we're full of space, but 6 months from now, 2 years from now, 5 years from now, if I'm budgeting for that, how much drive space am I going to need to budget for? Those are questions I'm going to have to ask, and I'm going to need to be able to use some method of doing that rather than guessing and putting my finger up in the air and waiting to see which way the wind blows, which is a lot of times, unfortunately, the way a lot of these decisions are made. In addition to that, being able to, looks like my slide got cut off there a little bit, but being able to provide some assistance in the form of recommendations. So it's one thing to be able to show you a dashboard full of metrics and be able to say, okay, here's all the metrics and where they're at, but to be able to then make some have some understanding of what to do based off of that is another leap. And in some cases, people aren't educated enough in the role of DBA to be able to make those decisions. And so we have some mechanisms in the tool that will help with that, which we'll show you in just a second. But being able to show not only what the recommendation is, but to also provide some insight as to why that recommendation is being made, and then also on top of that, in some cases, being able to actually come up with a script that automates the remediation of that issue is ideal as well. Moving on to the next one here, which we'll see, is just generally speaking, understanding down to the metric level what is normal. I can't tell you what's not normal if I don't know what normal is, and so having some way to measure that is key. And you got to be able to take into consideration multiple types of areas, for example, or I should say time frames, different groupings of servers, being able to do this dynamically from an alerting perspective. In other words, during the middle of the night, during my maintenance window, I expect my CPU to be running at 80% based on all of the maintenance that's going on. So I might want to increase my thresholds higher during those time frames versus during maybe in the middle of the day when I'm not having as much activity. Those are some things that obviously will be environmental, but things that you can apply to what's being managed to be able to help you manage that environment more efficiently and making it easier to do so. The other area, obviously, is being able to just overall provide the reports and the information to be able to answer those types of what-if questions. If I've just made a change to my environment, I want to understand what that impact has been so that I can, apply that same change to other instances or other databases in my environment. I want to be able to have some information or some ammunition to be able to make that change with some peace of mind and knowing that it's going to be a good change. So being able to do that comparative reporting, being able to rank my instances of SQL, being able to rank my databases against each other to say, which is my highest consumer of CPU or which one is taking the longest in terms of, weights and things like that. So a lot of that information is going to be available with the tool as well. And then last but not least is just an overall ability that you need a tool that's going to be able to handle whatever situation comes your way. And so what I mean by that is if you've got a large environment with a lot of instances, you're going to probably run into situations where you need to pull metrics that traditionally are not metrics that a DBA would want to even monitor in some cases, depending on that particular situation. So having a tool that you can make it that's extensible to be able to add additional metrics and to be able to use those metrics in the same form and fashion that you would use them if you were using an out-of-the-box metric, for example. So being able to run reports, being able to alert, baseline, all the things we're talking about is also a key part of being able to do this forecasting and making it so you get the answers you're looking for to be able to make those decisions moving forward. Now, the way Diagnostic Manager does this, we have a centralized service, a group of services that collects data against 2000 to 2016 instances. And then what we do is we take that data and we put it into a central repository. And then what we'll do with that data, obviously, is we do a lot to be able to provide further insight. Now, in addition to that, one of the things that's not on here is we also have a service that runs in the middle of the night, which is our predictive analysis service. And that does some kind of number crunching, and it helps to understand and help you as a DBA or acting DBA to be able to make those types of recommendations, to be able to also provide some insight in terms of baselines. So what I'd like to do, and this is just a quick example of the architecture, the big takeaway here is there's not any agents or services that are actually sitting on the instances that you're managing. But what I'd like to do is actually just kind of take you in to the application here and give you a quick demo. And let me just go out to and make that happen. Let's see here. Share my screen and monitor 1. There we go. And so let me know. I think, Eric, can you see that okay?
I got it now, yep.
Okay, so I'm going to take you through some of these different parts that I spoke on, and essentially let's start with the kind of things that are more along the lines of here's something that you need to do, or here's something that's a point in time in the future, and we're going to give you some insight around it. And this is being able to really anticipate, or I should say dynamically anticipate things as they're happening. Now, in the case of reports, one of the things we have in the tool are 3 different forecasting reports. And in the case, for example, of a database forecast, what I would probably do in the situation of being able to anticipate the size of a database over a period of time, and I'll just give you a couple of examples of that. So I'm going to take my audit database, which is pretty I/O intensive. It's got a lot of data going to it. We've got, let's see, we'll do this one here, and let's just pick the healthcare database up here. But the point is, I'm not just seeing what this space is on this. I'm able to say, look, let's take the last year's worth of data. And I have to, I'm going to fib here a little bit. I don't really have a year's worth of data. I have about 2 months worth of data. But because I'm choosing a sample rate of months here, I'm going to be able to anticipate or forecast out, in this case, the next 36 units. Because our sample rate is set to months, that is a unit, is a month. And then I would be able to then run a report to basically show me where we would anticipate our future growth for these 3 databases. And we can see we have a varying degree of difference here between, or variance between the 3 different databases, particular to the amount of data they're consuming historically. We can see the data points here represent the historical data, and then the line's going to be providing us with the forecast, along with the numbers to back that up. So we can do that, you know, at the table level. We can do that even at the drive level, where I can anticipate, you know, how big my drives are going to get, including mount points. We would be able to forecast this kind of same type of information out. But once again, depending upon the sample rate will allow me to determine how many units and where we're taking what we want to forecast out. Notice also we have different types of forecast types. So you get a lot of options and flexibility when it comes time to doing the forecasting. Now, that's one thing we'll do, in actually giving you a specific date and being able to say, hey, on this date, this is where we would anticipate the growth of your data being. In addition to that, though, we can provide you with other insights that are related to some of the analysis that we perform during the off hours and the service when it runs. Some of the things it does is it tries to anticipate the things that will likely happen based off of the history of when things occurred in the past. So we can see here actually a forecast that's providing us some insight into the likelihood of us having problems throughout the evening based off of things that have once again happened in the past. So obviously this is great, especially if I'm not a DBA. I can look at these things, but what's even better if I'm not a DBA is this Analyze tab. So before this was here in the tool, we would go through and show the product to people, and they would say, that's great, I see all these numbers, I see everything, but I don't know what to do as a result of that. And so what we have here is a better way for you to be able to understand if I'm going to take action to help with performance, if I'm going to take action to even help with the health of my environment, being able to have a ranked way of providing those recommendations, as well as useful tips and information to learn more about those recommendations, and actually having even external links to some of that data that will show me and take me to these the reasons why these recommendations are made, and in many cases even being able to provide a script that would automate like I said, the remediation of these issues. Now, part of what we're doing here with this analysis, and I'll show you when I go into configure the properties of this instance and I go to the analysis configuration section, we have a lot of different categories that are listed here. And part of that, we have index optimization and query optimization. So we're evaluating not only the metrics themselves and things like that, but also things like the workloads and the indexes. In the case here, we'll actually do some additional hypothetical index analysis. So it's one of those situations where I don't want to, in many cases, I don't want to add an index if I don't need to, but at some point there's kind of a tipping point where I say, well, the table is getting to the size, or the types of queries that are running within the workload make sense now to add an index, but it wouldn't have made sense maybe 6 weeks prior. So this is allowing you to dynamically get that insight as to things that will likely, like I said, improve performance based off of what's happening in the environment, what's happening within the workloads, and doing those kinds of things. And so you get a lot of good information here, as well as the ability to optimize these things automatically. So, that's another area where we would be able to help out in terms of what we call predictive analysis. Now, in addition to that, I should say, we also have other areas that I think just generally lend themselves to helping you make decisions. And when we talk about making decisions, once again, being able to look at historical data, provide some insight to get us to where we need to be to improve that performance. Now, one of the things we can do is we have a baseline visualizer, which allows us to selectively choose whichever metric we would want. And let me find a decent one here. Let's see. I'm just going to pick SQL Server CPU usage. But the point is, you can go back over however many weeks to kind of paint these pictures for you to see when your outliers are, to see, generally speaking, where that value falls within the periods of time that we've been collecting data. And then in addition to that, you'll also notice that when we go out to the actual instance itself, we have the ability to configure our baselines. And the baselines are really an important part about being able to automate things, as well as being able to be notified of things. And the challenge is most DBAs would tell you, is that your environment's not always running the same throughout the course of the day versus the evening and whatnot, as we mentioned earlier in the example with the maintenance periods of time when we have high levels of CPU or whatever that might be happening. So in the case here with these actual baselines, we can have multiple baselines. So I might have a baseline, for example, that's during my maintenance hours, but I could just as easy create a baseline for my production hours. And the point of doing that is when we go into an instance of SQL, and we actually have these multiple baselines, then we would be able to anticipate, and be able to perform some type of automation, some type of, remediation, or just alerting in general differently specific to those windows of time. So one of the things you'll see here is these baselines that we generate are using the historical data to provide that analysis. But more importantly, I can change these thresholds statically, but I can also automate these dynamically as well. So as the maintenance window, or I should say the maintenance baseline window comes up, these thresholds would automatically switch specific to the loads that I'm encountering during that window of time versus maybe in the middle of day when my loads are not as much, when the workloads are not as impactful. So that's something else to keep in mind in terms of the baselines. Obviously, these are going to be really helpful for you in terms of also understanding what is normal and being able to also understand and gauge when you're going to be also running out of resources. Now, the other kind of thing that we have in the tool that is going to help you make decisions, in addition to the baselining and being able to set up alerts around those baselines and the thresholds that you create dynamically, is, like I said earlier, just being able to run a whole myriad of reports that help me answer questions about what's going on. So as an example, if I said I've got, if I had 150 instances I'm managing. In my case, I don't, so we have to play the pretend game here. But if I had all my production instances and I needed to understand where is the area that I need the attention on, in other words, if I'm going to only have a limited amount of time to perform some type of administration to improve performance, I want to focus on the key areas. And so with that said, I would be able to say, based on that environment, rank my instances against each other and give me that ranking by contention type. So whether it's disk usage, memory usage, whether it's weights, whether it's response time, I'm able to correlate, or I should say rank, those instances against each other. Obviously, the instance that's at the top of each list, if it's the same instance, that's probably something I really want to focus on because it's obviously, once again, at the top of the list. So you have a lot of reports in the tool that help you in terms of ranking the environment at the instance level. You can do this also at the database level as well, where I can rank my databases against one another, particular to areas and thresholds that I can set. I can even set up wildcards here if I want to only focus on particular databases. But the point being is that I can compare my databases in the same fashion. Also, as far as other types of comparative analysis, and a big one in this tool is the baseline analysis that we have. So if you scroll down to the server's view here, you'll see there's a baseline statistics report. Now this report obviously is going to help us to understand not only what the metric values are, but for a specific instance, I could go out and for any of these metrics, be able to actually look at the baselines for these metrics. So whatever it might be, as a percent or whatever, I can go out and say, let's see the baseline for this broken out in the last 30 days, in which case it's going to show me the actual values versus the baseline, and I would be able to make some decisions using that information, obviously. So this is one of those situations where it's going to depend on what question it is you're asking at the time, but this is obviously going to help you for a lot of those questions. I wish I could say we had one report that does it all, and it's kind of like the easy report where you press a button and it just answers every what-if question you could ever answer. But the reality is you're going to have a lot of attributes and a lot of options to be able to choose from in these pull downs to be able to formulate those what-if type questions that you're looking for. So a lot of these reports are kind of geared towards being able to answer those types of questions. And so it's real important also that with these reports, and in addition, all of the things we've already shown you in the tool, as I mentioned before, having the flexibility to incorporate new metrics to be managed, even being able to create counters or SQL queries that are incorporated into your polling intervals to be able to help answer these questions that maybe out of the box we didn't anticipate to monitor. You can add that stuff, and you would be able to then do all the same things I just showed you: baseline, run reports, and create reports from that metric, and be able to answer and do a lot of these different types of things that I'm showing you here. Now, in addition to that, and one of the things we've obviously run into quite a bit lately is, first it was everybody flipping or switching to VMs, and now we've got a lot of people that are heading off to the cloud. And there's a lot of questions that are coming up around those types of things. Does it make sense for me to move to the cloud? Am I going to save money by moving to the cloud? If I were to put these things in a VM on a shared resource machine, how much money can I save? Those types of questions obviously are going to be coming up as well. So a lot of that stuff, keep in mind with Diagnostic Manager, we can add and pull from the virtualized environments of both VMware and Hyper-V. We also can add instances that are out on the cloud. So your environments like Azure DB, for example, or even RDS, we can pull metrics from those environments as well. So, there's a lot of flexibility and a lot of being able to answer those questions as it relates to those other types of environments that we see people heading off to. And there's still a lot of questions around this stuff, and as we see people consolidating those environments, they're going to need to be able to answer those questions as well. So that's a pretty good overview, I'd say, of Diagnostic Manager as it relates to this topic. I know that the subject of of business intelligence came up, and we also have a tool for business intelligence that we didn't talk about today, but it also is going to provide you some insight in terms of answering these types of questions as it relates to, you know, your cubes and all of those different types of things as well. But hopefully this has been a good overview, at least in terms of how this product can help with being able to formulate a good plan.
All right, good stuff. Let's see, I'll throw it out to Rick if he's still out there. Rick, any questions from you?
Yes. So first off, this was great. I liked it. I particularly liked extending out to VMs and clouds. I see a lot of app developers think that if it's in the cloud, they don't need to tune it. So
right. We still have to pay for it, right? You still got to pay for whatever it is that people are putting on the cloud. So if it's poorly running or it's causing a lot of CPU cycles, it's more money you got to pay. So it's not. You still need to measure this stuff. Absolutely, I agree.
Right. Yeah, I've seen particularly poor designs in the cloud. I did want to ask: would this product also be used? I know you mentioned the BI product, and you have tons of other products that interact with each other, but would you start looking at SQL performance individual queries in this tool, or would be other tools that would be used for that?
Oh, no, this would absolutely, and that's one of the things I didn't cover and I meant to, was the queries portion of it. We have a lot of different ways to identify query performance, whether it's related to specifically to weights like we see on this view here, or whether it's related to the resource consumption of queries overall. There's a whole number of ways we can analyze query performance, whether it's duration, CPU, I/O, and once again, we can also look at the workloads themselves to provide some insight. We can provide the recommendations in the Analyze section. We also have a web-based version that provides information around the queries themselves. So I can get recommendations on missing indexes and the ability to view the execution plan and all that kind of stuff. It's also a capability as well. So absolutely, we can diagnose the queries 7 ways to Sunday and be able to provide that insight in terms of the number of executions, the resource consumption, the weights, the duration, all that good stuff.
Okay, great. And then what's the load on the instances themselves with all this monitoring?
It's a good question. The challenge with answering that question is it depends, and it's just like anything else. A lot of what our tool has to offer, it provides flexibility, and part of that flexibility is you get to tell it what to collect and what not to collect. So, for example, with the queries themselves, I don't have to collect the weight information, or I can. I can collect information related to queries that surpass a duration of time of execution. As an example of that, if I were to go into the configure query monitor and I were to say, let's change this value to 0, the reality is that just basically makes the tool collect every query that runs. And that's really not the spirit of why that's there, but generally speaking, if I wanted to provide a full sample of data for all the queries, I could do that. So it's very relative to what your settings are. Generally speaking, out of the box, it's anywhere from about 1% to 3% overhead, but there's other conditions that will apply. I mean, it also depends on how much poor queries are running on your environment, right? It also depends on the method of collection of those queries and what version of SQL it is. So, for example, SQL Server, 2005, we're not going to be able to pull from extended events, whereas we would pull from a trace to do that. So it would be a little bit different in terms of the way we would go about gathering that data. But that said, like I said, we've been around for, I guess, since about, 2004 with this product. It's been around a long time. We got thousands of customers, and so the last thing we want to do is have a performance monitoring tool that causes performance problems. And so we try to steer clear of that as much as possible, but generally speaking, like I said, about 1% to 3% is a good rule of thumb.
Okay, and that's pretty low, so that's terrific.
Thanks.
All right, good. Robin, any questions from you? Maybe he's on mute.
Robin?
I'm sorry, I was on mute. You got a multiple database capability. I'm kind of interested in how, because you can look at multiple databases and therefore you can know the a larger resource space that's possibly divided up between various virtual machines and so on and so forth. I'm interested in how people actually use that. I'm interested in what the customers are doing with that, because that looks to me, well, it's certainly when I was messing about with databases, something that I never had on hand, and I would only ever consider one instance in any meaningful way at any given point in time. So how do people use this?
I mean, generally speaking, are you talking about just in general the tool itself? How are they using it? I mean, generally it's about being able to have a central point of presence of the environment, having peace of mind and knowing if they stare at a screen and they see green, they know everything's good. It's when problems happen, and obviously most of the cases from a DBA's perspective, a lot of times those problems happen when they're not in front of the console. So being able to be notified as soon as the problem is happening, but in addition to that, being able to understand when the problem does happen, being able to get to the heart of the information that is providing them some context in terms of where the problem, why it's happening. And so that's, I think, the biggest part, being proactive about it, not being reactive. Most of the DBAs I talk to, and I don't know, it's a good percentage of them, unfortunately, are still in a reactive type of environment. They wait for a consumer to approach them to tell them that there's a problem. And so we see a lot of people trying to break away from that. And I think that's a big part of the reason why people like this tool, is it helps them to be proactive, but it also provides them the insight into what is going on, what's the problem. But in a lot of cases, what we find, at least, and maybe it's just the DBAs telling us this, but the DBAs, the perception is it's always their problem. Even if it's the application developer that wrote the application that didn't write it properly, they're the ones that are going to be taking the blame, because they're taking that application into their systems or their servers, and then when the performance is bad, everybody points to the DBA and says, hey, it's your fault. So this tool is a lot of times going to be used to help in terms of making the case for the DBA to say, hey, this is where the problem lies, and it's not me. We need to improve this, whether it be changing the queries or whatever it might be. In some cases, it will fall in their bucket in terms of their responsibility, but at least having the tool to be able to help them understand that and know that, and doing it in a timely way is obviously the ideal approach.
Yeah, I mean, most of the sites that I'm familiar with, but it has been a while since I've been out there looking at various multi-database sites, but mostly what I used to find was that there would be DBAs that focused on a handful of databases. And those would be the databases that if they ever went down, it would be a real big problem for the business and so on and so forth. And the other ones, they'd just be collecting stats from every now and then to see they didn't run out of space, and they'd never look at them at all.
Gotcha.
And while you were doing the demo, I was looking at this, and I was just thinking, well, in one way or another, you've extend, just by providing something like this for databases that were often nobody cared too much about, because they have data growth, they have application growth at times as well. You're actually extending DBA coverage in quite a dramatic way. So that's what the question was really about. Is it that with a set of tools like this, you end up being able to pretty much to give a DBA service to every database that is in the corporate network?
Sure. I mean, the challenge is that like you said it pretty eloquently, it's like there's some databases that the DBAs care about, and there's some that they don't care about as much. And the way that this particular product, the way it's licensed, is on a per instance basis. So there is I guess you'd say, a threshold of when people decide, hey, this is a critical enough instance that I want to manage it with this tool. That said, there are other tools that we do have that are more, I guess you would say, catering to those, I guess, less important instances of SQL. One of them would be like the inventory manager, where we do light health checks against the instances. But in addition to that, what we do is we do discovery. So we identify new instances that have been brought online. And then from that point, as a DBA, I can say, okay, here's a new instance of SQL. Now, is it Express? Is it the free version? Or is it an enterprise version? That's probably a question I want to ask myself. But secondly, how important is that instance to me? If it's not that important, I might have this tool going out and doing its, generic, what I would call generic health checks, in the sense that they're the elemental types of things I care about as a DBA. Is the drive filling up? Is the server responding to issues? The main things, right? Whereas like with Diagnostic Manager, the tool I was just showing you, it's going to get down to the query level. It's going to get down into the, recommendation of indexes, looking at the execution plan, all that good stuff, whereas this is mainly focused on who owns what is it that I own, and who's responsible for it, what service packs and hot fixes do I have, and are my servers running with the main ingredients of what I would consider to be a healthy instance of SQL. So that, to answer your question, there is a little bit of a mix. When we have people looking at this tool, they're typically looking at a more critical set of instances. That said, we have some folks that buy every instance that they have and manage it. So it just depends. But I'd say overall, there's definitely a threshold of those folks that consider their environments important enough to have a tool like this to manage those instances.
Okay, another question before I hand it on to Eric. The impression one gets just from watching the industry is that databases still have a life, but all of the data is pouring into all of these data lakes and so on and so forth. That's the hype, really, and the hype never reflects reality. So I'm interested in what kind of reality you're perceiving out there. Are let's say the important databases within an organization, are they experiencing the traditional data growth, or are they, which I used to think of as 10% a year, or are they growing more than that? Are they, is big data making these databases balloon? What's the picture you see?
I think a lot of cases we're seeing some of the data being moved into those other segments where it makes more sense. With those other technologies that have become available as of recent, some of the bigger data stuff. But I mean, these databases, I would say, it's hard to generalize in a lot of cases because everybody's a little bit different. Generally speaking, though, I do see some divergence. I see, like I said, people are moving to the elastic models in a lot of cases because they want to grow the resources and not so much in other areas. Some folks are moving to the big data, but it's hard to get a feel for, like you say, the perception, because generally speaking, the folks I'm talking to or have the traditional databases and are using this on a SQL Server environment. That said, I'd say, in terms of SQL itself, I definitely think it's still gaining market share, and I think that there's a lot of folks that are still heading towards SQL from other places like Oracle because it's more affordable, and it seems to be, obviously as SQL versions become more advanced, and you're seeing this with the more recent things that are going on with SQL in terms of encryption and all the other capabilities that are making it an environment or a database platform that is obviously very mission critical capable, I guess. So I think we're seeing that as well, where you're seeing a shift. It's still happening. I mean, it was happening 10 years ago. It's still, I think, happening in terms of SQL Server, where the environment's growing and the market share is growing.
Okay, Eric, I presume the audience has a question or two.
Yeah, let me throw one quick one over to you. It's a pretty good question, actually. One of the attendees is asking, will this tool tell me if a table may need an index to speed up the query? If so, can you show an example?
Yeah, so I don't know if I have one for specifically adding an index, but you can see here we have fragmentation recommendations here. I also just believe we just had, and this is part of the Diagnostic Manager offering, the web-based version, where it's telling me I have a missing index, and we can view those recommendations, and it'll tell us the potential gain of that by indexing that information. The other thing I should just mention is that when we do the recommendations, for many of these, the script will be built for it. That one's not a good example, but you would be able to see, yes, the situations where an index, either duplicate index or the addition of an index, would improve performance. And like I said earlier, we do a lot of that through hypothetical index analysis. So it really helps in terms of understanding the workload to be able to apply that to the recommendation.
No, that's great stuff, and this will give me a good segue to a final comment here. Robin and I, and Rick as well, have heard over many years now vendors talk about self-tuning databases. It's a self-tuning database. All I can tell you is don't believe them.
Don't believe the hype.
There may be some small little things that get done dynamically, but even that, you might want to check it out and make sure it's not doing something you don't want it to do. So
Absolutely.
I think for quite some time, we're going to need tools like this to understand what's happening at the database level. And like Robin said, data lakes are fascinating concepts, but there's probably about as much chance of them taking over as there is of there being a Loch Ness Monster anytime soon. So I would just say, again, the real world has a lot of database technology. We need people, DBAs, to look at this stuff and synthesize it. You can tell. You need to know what you're doing to make this stuff work, but you need the tools to give you the information to know what you're doing. So bottom line is DBAs are going to be doing just fine. And big thanks to Bullett Manale and our friends at IDERA, and, of course, Rick Sherman and Robin Bloor. We do archive all these webcasts. Hop online, InsideAnalysis.com, or to our partner site, TechOPD.com, for more information on all that. And with that, we'll bid you farewell, folks. Thanks again. We'll talk to you next time. Take care. Bye-bye.